Okay, so regarding homework, so I will make sure from now on that my grading is a little bit more up to date. It's been a little lax, and because it's been lax on my part, I will extend grace to you because I'm being lazy does it or not lazy, but I'm behind. I shouldn't punish you guys. So you guys will have until Monday to get back any assignments you don't have. I will go through, and basically, if you have a 0 on an assignment, that means I don't have a file. So there's some of you I've gone through, and if I don't have a file, I just give you a 0. Yes, Peter.
I'm trying to access on campus so I can check to make sure I don't have any missing assignments. It's very much not letting me.
Oh, well, I haven't touched anything yet. So you guys should. That's your computer thing, not my.
Oh wait, it just worked.
Told you. So.
As soon as I bring it up, it starts working.
So you guys will have until Monday to turn in anything that has a 0. After Monday, I will not accept it. Except for homework. Anything that's homework, that's a completion grade. If that's a 0, that stays. But any project where you actually have to code stuff, that will that I will allow you guys to turn in to me. After Monday, that won't happen. If you don't turn something in, it will be a 0 and stay a 0. So it's always better to upload something, even if it doesn't work, even if you only have 2/3 of it done, to upload something rather than nothing, because if there's nothing there, I have to give you a 0, whereas if there's something, I can at least, well, you know, you got this or that part. Stockton.
It's just my username or password is correct. I'm trying to sign in to.
Are you just doing your first name dot last name as the login and that's it? Nope. First name dot last name. Your login, your login for the computer has never included the @WA Scholar. Does that make sense to everyone? Okay. Yeah. So that should help some of you guys's. Yeah. What else? Yeah, I think that is it. You guys are about to only have on campus. So finish. I'll give you guys 30 seconds to finish up whatever you're doing. Send any last minute emails. You can only go on campus in 20 seconds. What I want the rest of you guys to do is to get your in-class Pygame out. And we're going to start with that. Yeah, so everyone should be working, right? A lot of you guys just accidentally had a .zip and you didn't extract it, which is something I didn't tell you to do. So I understand why that would be a little that you guys might have issues with that. All right, so on campus only now. So, and hopefully that works, because it's almost immediate. So as soon as I said now, you guys should only be able to go to on campus. Oh, I actually know how to do my job. Thanks, Peter.
Well, I know filtering's difficult. Mr. Bischoff and I had a lot of trouble getting the filtering to not work.
Refresh the page. It might have cached stuff. Anyway, if you're playing Snake Monkey, you're okay. All right. So again, like I said, we are going to do the game for a little bit until probably about 11:15, because this started at 25. We go to like noon, so maybe 11:20. So does everyone's game at least do this? You at least have someone on screen.
Yeah, I got another error. I thought I fixed this, but it says it can't open, like, you know, that whole thing.
Do you in that file path? Do you have something .zip?
Yeah. Wait. No.
What is this? Well, then you just need to find the right file.
So at the end, what do we have to type in? So do.png.
Yeah. So the image for your player is dude.
You have to put backslash though. and then D7.
Again, guys, this code is on the student resources folder. You guys can download this and copy it and not have to wait for me to do, like, so if you're, that's the entire point of the student resources folder, especially with this game. If your code doesn't work, part of your responsibility at home, even if it's not homework, I don't assign it, is to get your code working for the next day. Because I can't spend 3 minutes with 6 students to fix their code. That's 20 minutes and everyone else is just sitting there. Part of your responsibility is either meet with me after school to get it working if you're confused, or at home to look at the code that I give you and your code and find the differences and fix it yourself. Did you get in, Stockton?
It's like the Wi-Fi's really slow, but I just got into my school app.
Okay. Yeah, so, okay. Yes.
It's not .zip, but the image doesn't show up either.
Okay, so then you need to find, do you have 3 variables here? Do you have player, grass, castle? Darn it, why do I have it a second hour then? I suck. So you guys only have player, and you guys don't have any of that.
Wait, is the file in class Pygame? That file? Yeah.
So this is what you guys have,
Also,
right?
you can't name your file Pygame.
Do you guys have a while loop or no?
No.
This is great. I'm so good at my job. Okay.
Really are.
So this is what you guys should have.
Yes, that is exactly.
Black screen with the bunny.
Yeah, I got an error when I tried the bunny.
Okay, I'm going to pause the recording. Is it? Okay, there we go. So for those of you who have a .zip file, what you need to do is you need to navigate to that location where that .zip file is. So for you guys, it's probably on your desktop somewhere. And so this is what a .zip file looks like, right? This is a homework assignment of you guys that I downloaded a while ago. So what you need to do is you need to right click, you need to go to extract all, and then this will pop up. Extracted compressed zipped files. Don't touch anything. Just click extract, and if done correctly, you will now see second hour if statements unzipped in the exact same location of your zipped file. Once that's the case, all you need to do is in your code, is it this one? You just need to go in your file path. You guys probably have something like this, resources.zip. You just need to go to that and delete the .zip part, and that should fix it.
So I just have the .zip part. Mine is already unzipped. But it should say resources. It should say
It works now? Okay. Again, sorry about that. And sorry for this sigh of exasperation.
You didn't tell us about that, like last class. You didn't tell us about zip files.
Yeah, but I didn't tell you how to extract them. So I just kind of assumed everyone did, so that was my bad. Ezra.
Yeah, I don't get an error when nothing shows up. I haven't been typed.
Like nothing shows up as in it's all black, or
Why is it so slow?
do you have this part? And do you have the update? You need those two in order to see it. Anything. Okay, you need the update in order to see stuff. All right. So, oh yes.
Give me your Pygame surface object has no attribute built.
Has no attribute what?
Has no attribute built. B-I-L-T.
Yeah, it's blit. All right. So, all right. So we're gonna continue now with our game. Oh yeah, that's gonna take a while for you.
Okay, I can still like write the code.
Yeah, write the code, but
it's gonna have the wrong file path.
yeah, but then you can just copy that with the code you have at home.
I'll illustrate it, but I don't have
Or you can just type it and just get, you know, you type it and then you can just download this once you get home to yours. All right, so now what we need to do in our video game, we have loops, right? Game is just a loop until you die, and then it starts another different loop. So what we're going to do is we're going to have a variable that controls whether or not our game is running or if it's not. So we're going to have a variable called running equal, and we're just going to make it 1. Okay? And then, yeah, I'm not going to do the other one. Now we're going to have while running equal 1. So this is the main game loop. Yeah. Everything for the Yep. So these two things here, we also want to indent to put them in the loop. Otherwise, we'd never see them. Mm-hmm.
Wait, hold on. Why did you remove the Pygame? Oh, I see. Never mind.
I didn't. It's right here. Now there is something you can use, I believe, instead of update, you can use pygame.display.flip. Update's better because it updates the whole screen. I think it's slightly different, but with flip, you can actually update sections of the screen. So just something that you can throw out there, the difference between display and flip. If I only want my top left to update for whatever reason, I have a level change or whatever, you can tell it I want, you know, you can tell it a certain section of your screen to update. But that's neither here nor there. That's just some extra info for you guys. So once you have this, what we're going to do when we run our game right now, this is what we have. It crashes. Oh, great. Well, mine just crashed, but it also could be because I'm doing like a bajillion different things at once.
Yep, it says unexpected indent. Oh, I didn't indent.
So notice it's crashing, and even when all right, my code's something's probably wrong with my code.
No, I didn't indent it. That's what happened.
All right.
Oh, that's what his name's Dude, right?
No, it still says unexpected. Oh wait, hold on.
Well, I'll let you fix that because that's something I can't fix unless I get up and look at your screen. So right now our code we don't have a way to exit or quit our code. So what we need to do is we need to put in a loop that tells us how to exit our code. And so let me just open something real quick. Throw this over here. Uh-oh. Where is it?
Module named Pygame.
What?
When says there's no module named Pygame?
Oh, you have to pip install it. Just write the code. All right, I gotta pause this and find the code. So what we need to do is we need to code away for this game to end. And so what we're going to do is underneath update, we're gonna have a for loop. Now for event, so write the word for event and then pay attention up here because this concept is importante, muy importante. So the way video games work is they wait for your input, right? So when you're playing a video game, your character doesn't do anything until you push the joystick forward or you hit a button and it corresponds to an action. Same thing, we need to code that in for our game. So the way it works is the input, your code is waiting for an input, and all inputs are basically in a pipeline. Who here has played Tetris? So you know how you have the pieces waiting? And you have to then decide what to do with them as they fall? That's the pipeline of our code. We have a pipeline that fills up with inputs from us, and our code cycles through them. We need to code that, and those inputs are coded as events in this pipeline. So what we're going to do is we're going to say for every event in this pipeline, we're going to evaluate what it is. So for event in pygame.event.get, pretty simple, right? We're going to get the event in Pygame. So this is a pipeline filled with mouse button clicks, keyboard. If we resize our screen, if we click the red X up here, all of these things that we do to the game get stored in this pipeline. As the computer runs, it's checking them. So by stored, it's not like if I click 30 times, it stores 30 clicks in that pipeline. It's just as things go in, they go in this pipeline, and your code cycles through that pipeline super fast. So does that make sense conceptually what we're doing? Is there anyone that doesn't understand that? Because I can do a drawing. I can use the
I
whiteboard.
don't understand that.
Okay. You're just saying that.
I would like to see the drawing to more understand.
I understand it somewhat.
Uh,
I feel like it's
The drawing, yeah, the number.
The drawing's going to be helpful. Okay, so this is our game. And as we, this is our, oh my gosh, my computer's so warm.
Dude, it's toasty.
So this is our bunny,
It's toasty.
and it's chilling right here. As we, on our keyboard, uh-oh, everything's going haywire. So this is our keyboard.
That's what mine looks like.
And as we click up, this gets put in, into a cable, an electrical signal, and we can basically think of these events. So I've clicked up, and then I click down, and then I mouse button, and then I space, and then I go left, and then I go right. So as we're doing this, you can think of each event being put in this pipeline, and as we type, our loop is going through these. So it's evaluating, is this event one we've coded for? If it is, which one is it? Is it a mouse button? If I click up on the keyboard, is that a mouse button? So it's not going to do that. Is that a keyboard thing?
Yeah.
Okay, so it's a keyboard up. What are we going to do? We move our character up. Move up. So then he scoots up until we stop. And then it cycles through each one of these at like 30 per second. Right? So you're not going to be able, about 30 or so a second. What?
That's like one every.
Actually, no. It cycles through the code 30 times a second, and every time it cycles through the pipeline. So per second, it's cycling through any number of whatever's in here. So this is our pipeline. This whole thing is Pygame. My surface is so warm right now. Pygame.event.get. This right here is the command for all of the inputs that we put into the computer, into the game. And then our event, so for event in all of this event is the individual item, individual keystroke, individual mouse click, all that sort of stuff. Does that help? Peter?
Have you seen Mr. Max stand on the back of the computer?
Yes. So, now what we're doing, I scroll past it. For event in pygame.event.get, if the event.type equal. While you guys type that, you guys should remember, what? Yes. This is not, I will start this out. This is not the most efficiently or well-written code. as the years have gone by, I've actually condensed it even more than what it originally was, but there's probably a way to make it better. So what does this output? What does the function type, Brendan?
It's gonna say integer.
Yep, integer. So what we're saying is if the type of event is a specific one, we're going to do something. Just like, if, you could do x is type x if x equal. I don't think this will work, but I don't know how this works. I've never done this. Yeah, I don't know how that works. But regardless, if the event.type is Pygame.quit, capital quit, and that's it, no parentheses after it. What we then do is we do Pygame.quit, lowercase, and then exit. Your code will work with just one of these, but one of them actually stops the code and the other one closes the window. So just put them both. Most things online, you see both of them, I think. So now hopefully when we run it, we see our bunny, but when I click the red X, it closes, which we didn't have before, so that's good. Nope. If you don't have this, at least not for me, my computer crashed, or it would. It like flips out. So it says, like, I can't move it, and then it says not responding. Because we're in a loop, and it's going, and then you try to do anything, it crashes.
But it does say your program is still running.
Yeah, but, so we want to keep that here. We want to keep that. David.
So, like, after I do this, I have some kind of fun outline around dude, which I didn't have before.
Yeah, it's because yes, well, I will. Yeah. So we have 2 of the 3 lines of code we need to successfully put things on screen. Until we move our character, doesn't matter. Basically, what you're seeing is every iteration of every blit of your character in the exact same place. If you move your character, you actually get an echo. You see your previous blit, so it's like a. Did you guys ever play solitaire and win? You know how the cards, like, you see all of the cards as they move? You see that. You see every previous blit of your character.
Like when you do like the shutter, you like something.
Yeah, exactly. So there's one line of code that gets rid of it, but we don't need that yet because we only have our guy isn't moving. So what we need next is to get our background. So we have our guy on screen, but we don't have a background because you can't have a bunny running in black, right? He needs to have something to run on. But if you look at our images, so in our resources folder, we have our background is grass, right? Is just this little, that's actually much bigger than it is. It's actually only 100 pixels. But if this is our grass, and this is our screen that we're playing on, as soon as it loads, does this 100 by 100 pixel, which again, this is too big, will that fill our entire screen? No. So what we're actually going to do is we're going to use loops that we just learned to tile the image across the screen until it fills the whole screen. So with one image, you can have it go and it will fill the entire screen. Brendan.
So theoretically, you could have like a 1 pixel image, and then you could just make it fill the whole screen.
You could, but it would blit like, what's 640 times 480?
Oh my. A lot of
So it would blit that number of times and it'd really slow down your computer. So you could, one way to make this code better is instead of blitting one image 16 times, what could you do? Find a bigger image and blit it once. Which, fun fact, if you want to have your character moving you can actually, and I did this for an example for an example game. I had a guy flying, a little plane flying, and I had a really, really long image, and I just slowly blitted it this way. So it looked like your character was flying, but all it was one static image that scooted this way, and you only saw a little tiny bit of it.
That's cool.
Yeah, which they do a lot in animation. They have the same background, but they just slide it. Like, there was actually a joke made in some animated TV show, and I can't really remember what it was, but they joked about having the same door as they were walking down a hallway. They joked about having the same door with the same name, and then they were like, oh, the animator saved time by having just a repeating background. That's all you can do, and it's a super easy way to have your code, to have a moving background, and all you're doing is you're sliding the image in and out of frame. So what we're going to do is we're going to do a little for loop and to tile this image across all of this. So I'm going to scoot that. I'm actually going to close that for now. So what we're going to do is we are going to have for x in range, which is our typical for loop, right? So copy that down, and while you guys are doing that, I'm going to pull this up, details. So once you have this for x in range, what I want you guys to notice, 100 pixels and 100 pixels, right? So what we're going to do, we don't want to, could we hard code 100 pixels into our code?
Yeah.
But why don't we like doing that?
Because we make stuff easier
Stop.
with them.
What?
Inefficient.
It is inefficient. Well, technically it might be more efficient because your computer doesn't have to think. It just takes the 100 and does something with it. But what if we want a different image that's potentially bigger or smaller?
And you have to redo it.
We have to redo it. So any single place we type in 100 by 100, we have to redo it, which can screw us up because we may forget one. We may forget a place where we did 100 by 100, and then our game doesn't work. So what we're actually going to do is we're going to tell Pygame to automatically get the height and width of the image and do math with it. So instead of typing in 100 by 100, we type in a command, and it evaluates the image, gets the width, and does stuff with it. Pretty cool, right? Thank you. Resounding success. So with for loops, oh, all right. So if we only have one number in a for loop, where does it start? 0, correct? So we need to do, oh, and last thing, what type of number has to be inside of range?
Integer.
Integer. Why an integer, Peter?
Because you can't iterate, like, do something like 3.5 times, like with the half times.
Exactly. So we have to have a whole number because, like Peter said, we can't loop through something halfway. So we need to type in the command integer because we're going to do some math that may give us a float, and we can't use that. Even if you have a whole number, so 1.0, that 0.0 breaks the code. It has to be a whole number. So integer. What we're now going to do, width. Who can tell me what width equals number-wise right now?
640.
640. And what does that represent?
The width of the screen.
The width of the screen. Then it is divide by grass.get width. Yeah, we haven't. We need to define this variable, but it's super easy. So we'll do this line and then define the variable. Grass.get width. What do you think that's doing, Ezra?
It's probably like taking the grass and doing the width so that you can like split the grass that much.
Perfect. It's exactly it. It's taking our image and getting the width of it, which is what is it again? Does anyone remember the dimensions of it?
480 by 640 by 480.
That's our screen. That's our big game that we're playing on. 100 by 100. Nice job, Ezra. So it's 100. So we're dividing 640 by 100, which gives us 6.4. What's the integer of 6.4? 6. Okay, so this is for x in range 6 is what this adds up to. So let's define grass real quick, and then we'll come back to, because we actually need to do one more for loop underneath this. So the easiest way to do this is you copy this line of code, the player line, Control C, Control V. Yep, the whole line, all of it. Player equal pygame.image.load, and then the entire file path. The reason why all of our images are in the exact same spot is so that all we need to do is to change the name of the file to load it into our game. So instead of having player, we change this to grass. And then at the very end of this line, instead of having dude be our grass, although it's pretty funny if you don't change that, it just tiles the bunny. So you have a bunny running on top of all your other bunnies. So if you want to see what that looks like, you can. But for now, right now, let's get the grass going and get that correct. So then we change dude to grass. So it should these two lines, the only difference should be is instead of dude you have grass, and instead of player you have grass. And all of our images from now on are going to be done exactly like this. We're going to. What's your error?
Unexpected and unintended.
Yes, if you run your code, you'll get an error right now because we don't have anything underneath this for loop. It'll break, so you can't do anything yet. So for x and range, so now that we've loaded grass, so if we blit an image right now, it'll tile across and that's it. So let's see what that looks like. So how do we put something on screen, Sonny? How do we put something on screen? What's the command or code? Do you remember? I'll give you a hint. Blit, yep. What that is that's the code you need to put something on screen. So what we're going to do is we're going to go screen.blit, not screen.lit, screen.blit. Little typos can really mess you up. So we're going to do grass, and then what needs to be in the second set of parentheses? 0, 0. But I got rid of those parentheses, so that's an oopsie on my part. 0, 0. So when we run this, we're going to get, what are we going to get?
Whoa! Green triangle.
Green square technically, but yes. So we have it up here. We haven't tiled it because we just haven't. Because 0, 0 is where at on the screen?
The top one.
The top left. Notice, yes, Brendan?
Yeah, so when I ran it, I got a syntax error and it's highlighting. So you know how you just did like a screen.blit?
Yep.
What's the other screen.blit, like below that?
You're missing a parenthesis probably. Do you have two sets of parentheses?
Yeah, no, I don't. I have
Yeah.
1.5.
1.5, yeah, we can't have that. Yes, Catherine.
How do you have like the grass under the belly, not over the belly?
Oh, good. That's a very good question. Way to bring it up. So the layers, so in coding you have layers, obviously, right? The first thing, so if I were to lay a piece of paper on the table and then I lay a book on top of it, what do I see? I see the book. But if I put the book down first and then I put the paper, what do I see? I see the paper. So the order in which our code says blit this, blit that, blit this is the order that things get layered. So the first thing, say that? What?
That's gonna matter when we make the game, with the order of the blit.
Yeah, so the first thing you want to blit is, what do you think?
The background.
The background, and then you have your characters, and then you have, you know, if you got Martians running around or whatever your game is, It's the order in which we type blit. So to answer your question, Catherine, if I had to guess, you have player before this loop. And it needs to be after the loop. Brendan?
Yeah, so when I used to get like a button with everyone else, but now when I run my code, like it just doesn't show up and I can't exit out normally. So like
So what pops up?
like the game, like the screen pops up, but like I don't have the button anymore and I don't have the tile. And then I can't exit out, I have to like exit out of the shell. Like I have it like all of the indents right. I have all the indents right in the order. It looks like that.
All right. Well, let's finish this loop, and then I'll come take a look at yours specifically. But for as best as you can, follow along, and then once we're done with the background, we'll change gears. Okay. So we're getting 0, 0, and just so you guys know, the top left of our screen up here is what? What's our XY coordinate? 0, 0. And the top left of our image is blitted there. Just so you guys know. The top left of the image is blitted where you tell it to go. It's not the center. It's not anything else. It's the top left. So we're going to have one more for loop. Now we're going to do for y in range. So again, just our basic for loop. We want something to happen a certain number of times. And not because we're lazy, but because we're efficient, we're going to do what? Copy some code. Code we've already written. So instead of having to type all of this out again, just copy it and paste it. And then all we need to do is we need to change two things. What do you guys think that might be?
Height.
Yes, nice job. So I just type height here, like that? No. I don't know, maybe.
Replace the width with the height.
Replace the width with the height, yes. Oh, I do that quite frequently, actually. I think it's because of this game I learned how to spell it correctly. All right. So I can't have this blit. Well, first, hang on. Is everyone? How's everyone doing? Everyone caught up? Okay. Yeah, Brandon. We'll get to your. We have like 2 more things to do, and then boom, you have your background. Ezra.
I had the same error and I figured it out. So after get width, you have to make sure you have the 2 close parentheses after, like before. I do have that. You do?
Do you have get underscore width?
Underscore?
And you have a colon instead of
Oh,
period.
no.
Okay, that's
There it is.
Oh, nice job, Peter.
Wait. What?
Wait.
Mike.
So, hold on.
Expected and
An indent. Yeah. So
Yeah, that's for.
so right now this screen.blit is in the wrong place. We have to indent it, otherwise we get a syntax error like this. It's saying an expected an indented block. That means because it's a for loop, the next line has to be indented, period.
Yeah.
All right.
After you close your game, does it ask if you want to kill the program?
Yeah, that's normal. That's how it's gonna work. Okay, so
Wait, can I exit off that?
Can we change what that says? Like, I'm sure you want to.
no, I'm sure you can figure it out, but we're not gonna cover that. So Josh D, what are we done? Will it tile across now?
No.
Why do you say that?
Because we limited it once still. It'll just do the corner.
It'll just do 0, 0. Correct. So in order for it to move, what do you think we need to change these two? We have to get rid of 0, 0. So if we want stuff to be dynamic, dynamic means changing or able to change, be flexible basically, as opposed to static. Static, especially in networking and computing, static means it doesn't change versus dynamic means it does change. Stockton?
Maybe like make them variables and then define the variable as like
X equals X plus 1 or something like that.
Very close. Yes, we do need to put variables in here.
Use another for loop. So when X works out, you already used it in the for loop.
Well, we do it in the for loop specifically for this reason.
Oh.
So if we do X and Y, X is going, in our first loop, X is what? If it's range 6, X is,
It's like, it's saying 1, 2, 3, 4, 5.
right, it's 0. And then the next time it iterates through, it's going to be what?
1,
And then it's going to be,
2,
and then it's going to be up until 6. So when we run this, hopefully it doesn't crash. Well, that looks the exact same. Why do you guys think it looks almost the exact same?
because it's moving very slowly.
Not moving very slowly, it moved,
1 pixel.
yes, 1 pixel a loop. So total, it moved like 6 pixels.
And so why isn't it moving again?
So who just said that? Yes. Why is it times 100?
Because every iteration is getting one larger. So just
One what larger?
one. Well, the variable is adding one every time. So if you add how long the whatever it's called, the background is.
Yes.
So, yeah.
The width of the image. So we need to do, instead of x, we need x times 100.
1.
Say what?
Because X is 1.
X is 1, but 1 times 100 is
Okay, yeah, so it's
100, and then it's 200, and then it's 300, and then it's 400, and then it's 500. X times, and then we're going to do y times 100. Screen depth look flat. Okay.
Whoa, almost. Ah.
But
Wait, what? It covers some.
That's because we used we rounded down instead of rounding up in the beginning with the width and the height.
That's 6, not 4.
Wait, what's happening? Did you already play those?
No, it's just below.
no, he's close, but no.
Can you see if it like
He we didn't round down. What's the thing with range that always is confusing? Hang on, Catherine.
Get the integer.
We did the integer, right? But range, if we do range from range of 10, what are the 10 numbers we get?
Okay, 0 to 9.
0 to 9. So this is pixel number 600 right there. So what do we need to do?
Times about 1 plus 1.
Who said plus 1? Yes, we need to add plus 1.
Oh,
Wait, is that way the spaces there? I was staring at them.
That's why, yes, that's why I had the spaces there.
I put the spaces there because maybe it's less confusing because there's so much stuff.
Now when you run it, we have a full background.
Oh, wait, no, I put it in the wrong spot. Hold on. I thought you meant.
This is epic.
Yes.
Don't worry, now we have
Oh, I have it almost
the green background.
like almost the whole like X territory, but like going this way, a little part in the bottom.
Did you put it for both?
Because you need plus 1 for the width and the height. Yes.
If we did this, we would just have a little extra, extra blocks on the side that we don't see.
Correct. Yeah. Exactly. Because our screen is 640 pixels wide, our code is actually going 700 pixels over. So we do have an invisible part of our game that's off screen, which is totally fine. And there's plenty of games that do that. I play a game on my phone, Bloons Tower Defense 5. So much fun. And you can actually, balloons spawn off screen and come in. So if you have a tower close enough to where they spawn in, you can pop the balloons before they're even on screen.
Spawn kill.
Exactly. Which is actually, we do that with our badgers. With the badgers that run across the screen, we spawn them off screen and then have them run on screen.
So you spawn at like 700 or something?
We spawn them actually right at 640.
Oh, because they'd be to the right of that.
They're to the right of it, so their entire image is off screen, but then they immediately start running on screen Brendan.
Yeah, so that also happens in like Mario a little bit. So like if you like start to play Mario, which I'm sure you have, like if
There's
you,
like 30 of them. Which one?
okay, like the very first one, like the Super Mario Bros.
Oh, yeah, yeah.
NES, yeah. So like if you like run forward, like let's say you're standing somewhere and there's no enemies coming towards you, but like if you start inching forward at some point, like enemies will come off screen. Like at a certain point, it's gonna start like spawning, right? Kind of.
Yes, yes. So it's the way a lot of games work is once you get to a certain point. So if position is this, do something. So what we've done, what you can do in our game is you can say if their position is this, spawn this guy. So you could code a spot in your game that if your guy touches this spot, you know, who here has seen Indiana Jones?
Which one?
The first one. Who here has seen the scene where he takes the idol and then the ball starts rolling? Even if you haven't seen the scene, even if you haven't seen the movie, odds are you've seen that scene or parodied somewhere. You could have something to where if my character goes to the middle of the screen, so if my character goes right here, his image changes to him holding an idol, and then you have like 30 bad guys come at once, and then it chases them or whatever. So if your character goes to a certain location, you can then have aspects of your character change, and that's what they do in a lot of video games is if you get to this point, do this. Or in other games, as long as you're in this specific area, bad guys will keep coming. You need to like work your way through the area, and you can't just sit there and wait. Okay, so that is all we're doing for today. On Friday, what we'll do is we'll actually code in the ability to move.
Oh, that's cool.
Yeah. What we're gonna do today, I'm gonna stop the video because that is just save that.